Next, we have uh, a student, a former student of C.S. Wu, Professor Evelyn Hu from Harvard University. She actually completed her PhD under Professor Wu, and now, of course, is a world-renowned physicist. Here, the screen is yours, Evelyn.
Thank you. Would you let me share the screen, please? Hold on.
Here it is. Yep.
Thank you. So thank you, Dashrang. Thank you, everyone, for letting me participate in this symposium today. I had the privilege to be a graduate student under the mentorship of Professor Wu. And I want to, this is a chance for me to again give thanks and also reflect on in the long term of the impact that Professor Wu had on my career, as you've all been discussing, the greater impact she's had in a global sense. The title, The Lighted Way, The Long Journey, I want to explain it a bit. I use a quote by Mustafa Kemal Ataturk. You may or may not know he was the founding father of the Republic of Turkey and its first president. But teaching is something that is universal and important to all of us, no matter what our ultimate careers. What Ataturk mentioned is that a good teacher is like a candle. It consumes itself to light the way for others. And I think what everybody has been speaking about today is how Madame Wu set and guided and lit the way for many people. But the other part of my title, The Long Journey, I want to imply that in some lessons that people give us as they light the way become evident only in the fullness of time, in the course of a length of career, and those are my reflections. But it's very appropriate as we gather here today, the 110th anniversary of her birth, to laud the impact she's made over the long term, but also in the shorter term, my reflections on how through a different lens she's influenced me. Let me take you back to the setting, Columbia University in the 1970s. My PhD research, and you can see me setting up, was at Brookhaven National Labs. It was at the alternating gradient synchrotron, the C line. My PhD thesis was the mass and magnetic moment of the antiproton. That sets the stage, but part of the stage is to mention and to begin to give you a short synopsis of some of those lessons over that long journey. One of the lessons was to explore nature broadly. And I think I was aware as a graduate student, but didn't fully appreciate that there was a breadth of activities going on in the same lab. You all have heard of not only the parity violation experiment, but the breadth of Professor Wu's interest in exploring weak interactions and beta decay. My particular experiment was one of several in, quote, exotic atoms, where hadrons, for example, the antiproton, played the role of an electron in hydrogen-like atoms. It was a unusual way to do particle physics, but using the methods of atomic spectroscopy. But I mention here I show here some of the publications and the titles of those of my colleagues who were in C.S. Wu's labs about the same time. Some had to do with hidden variables, and this is to presage Lars Brink's discussion of entanglement. Hidden variables is critical in the idea of what kinds of experiments you can do to probe the quantum mechanical world, time reversal tests and nuclear structure studies. And I also note Mossbauer studies. So she studied sickle cell anemia by the techniques of Mossbauer techniques that was going on. So a very socially relevant role of her science. She did her science everywhere in the accelerators of Brookhaven, in the salt mines, the Morton salt mines to explore double beta decay, in the basement of Pupine with low temperature experiments that ran whenever the subways would allow the vibrations to subside enough. Another lesson that has been mentioned by many is, by example, dedication and adherence to the highest standards of work. So you've heard and maybe seen quotes like this. These quotes that I take are from Sharon McGrane's publication, Nobel Prize Women in Science. And these are quotes that she gave in her discussions with McGrane. That importance about physics and the total commitment, not just to how demanding she was, total to science. I mention this not because this is a well-known feature of Professor Wu, was highly lauded, but I want to say that this is one of those lessons that come perhaps in the fullness of time. You can imagine that as starting graduate student, we understood her approach to science. We weren't perhaps yet fully able to embrace that commitment, that belief in giving our all. It's something that was important to present to us, but it's something that we believe, I think individuals believe only in the fullness of time. Another lesson is to be outward looking, to not only exist within your bubble, the bubble of your own group and your own research, but to look to the community and to the profession. So it's been noted many times that Professor Wu was the first woman president of the American Physical Society. This is a notice given by In Physics Today in 1973. And I want to say from the vantage point of a student, we realized that this was an honor. We realized that it was important. We didn't fully realize, and I certainly didn't fully realize at the time, the extent of that obligation and the extent of the responsibility. But we knew that she was bringing the outer world, the full professional world into our labs. And the bottom right-hand side, this picture is, it was a dinner before Madame Wu actually retired. So it was dinner from that many of us had. And you can just see that it was, these are my fellow student and staff colleagues at the dinner table with Madame Wu. So bringing the world from the outside and the idea of community and professional responsibility, I think is critically important was a critically important message to take to students. Then another lesson, the last lesson I'm going to point out is that long journey, taking the time to wait for results and impact. Whether it's over a scientific time to realize the full impact, it's a time that you need to realize what's important in an individual career, an individual experiment. And I was very privileged to be part of the celebrations 10 years ago in honor of Madame Wu's 100th birthday. They were held in Taicang, her hometown. These are pictures from that visit. This is in the garden of the Mingde Middle School that you've heard of, where her father was a teacher. And a part of this is apocryphal, but here is a plaque that states this. There was a planting of a tree in 1915, supposedly done by Wu Zhongyi, C.S. Wu's father, in honor of her birth. This is a plaque that mentions this, the name of the tree, and also this plaque was set there on the 100th anniversary of her birth. So as we take the long road, we still, that long journey, still today, we appreciate the consequences, the seeds that she's sown, the lessons that she's given us, and to realize that sometimes the full realization of lessons and the full realization of impact takes time and the right time to come to fruition. I give another quote from Professor Wu. You must work very hard at the beginning. It is hard to push the door open and get inside a subject. Once you understand, it's very interesting. Pushing that hard door to open, that has been referred to many times by many speakers. And certainly the difficulty of pushing and learning. For me as a student, I knew it was difficult. It took the fullness of time to tell me its worth and its importance. So if I take those lessons and I take some of the important concepts from those lessons, I've very craftily made them spell endow. And that is the thanks that I want to give to Professor Wu for endowing and lighting the way for my career, and indeed the career of many people and for a global community. Thank you very much.
Evelyn, your talk reminded me of a famous Chinese saying, which I will paraphrase it now. We often say 百年树人, and I'm going to say today is 百年树科学家. Thank you. The next speaker is Professor Gao Haiyan, who is at Brookhaven National Lab, as you can see, but she's also a distinguished professor at Duke University. Haiyan, go ahead. The screen is yours.
Thank you so much. I cannot really share my screen, looks like.
Yes, you can. Someone will allow you to.
Okay.
Here it comes. Yep.
I am so honored to have this opportunity here to speak, and I would like to thank all the organizers for inviting me, especially Professor Feng. And so Madame Curie has been an hero and role model to me in almost my entire life. And I grew up in China in the era we were taught women are holding half the sky, and I really felt that was the case when I was growing up. And very lucky, had very inspiring teachers who were very encouraging and encouraging all of us, boys and girls, to pursue science subjects. And it is not an overstatement. When I was growing up, all the girls who are interested in science, I think we all know about Madame Curie and Madame Wu, and both were experimental nuclear physicists. And for all reasons, we all felt extremely close to Madame Wu because she looked like us, right, as a Chinese girl growing up. And you have heard about nuclear physics. Professor Gates gave a beautiful introduction of nuclear physics. So that saved me time. So as we are running late, so I would not spend too much time talking to you about the wonder of nuclear physics. So let me just move on. And you also have heard the famous, beautiful experiment, parity violation in polarized Kubo 60 beta decay. And because of polarization, because of Madam Wu's experiment made such a deep impression on me, I always was extremely fascinated about ways to polarize nucleus. And in her experiment, as you already have heard, and the technique was based on strong magnetic field and low temperature. So when I went to Caltech in the late 1980s, and I became very interested in this case using laser to do so-called metastability optical pumping and to polarize helium-3 nucleus. So you may be wondering why you want to polarize helium-3, because as we know from the speakers before, neutron decays because of beta decay. So you really don't have a stable or a neutron which lives long enough for us to really look what's inside the neutron. So we use polarized helium-3, or we use helium-3, which is stable. And if you look at the helium-3 ground state wave function, and about 80% or 90% of the time, you can think about that as a polarized neutron. And that is how we can actually do scattering experiment to look what is deep inside the neutron. Now, neutron and the protons are building blocks of atomic nuclei. They are extremely important to us. And we know there is a theory called quantum chromodynamics, which describe strong nuclear force, but we really don't know how QCD really works in the so-called non-perturbative region. So we use electron scattering, for example. We also use photon as a microscope in order to look deep and deep inside. So throughout my career, I have been using polarized helium-3 a lot to study various aspects related to the neutron structure. And connecting to Madam Wu's work in terms of parity violation in weak interactions, I also worked in terms of using polarized helium-3 as a way to look for neutron electric dipole moment. And the non-zero, or the existence of neutron electric dipole moment, is a direct evidence for time violation or time symmetry violation, which give you insight about CP violation because of the CPT invariance. And this is very important, as you have heard from Professor Gates early, that that help us in some way to understand why everything we know now is matter instead of matter and antimatter in equilibrium or symmetry, so-called baryon number asymmetry of the universe. So I also use polarized helium-3 in order to study neutron or EDN, and I work on that for a number of years until very recently have been focusing on a quantity which actually connects standard model search by doing electron scattering measurement. So let me just end by saying that we have heard role model being very important, and I have been extremely grateful and also blessed by having such a wonderful role model, which is Madam C.S. Wu, and thank you very much.
Thank you very much, Haiyan. It's always moving to listen to how people get motivated and inspired. The next speaker, which we will show a video, although he's also online, is Professor Su Qian Xu. Professor Su Qian, if I have to introduce him, it'll probably take 3 hours. Which I will not. You can just see he is one of the rare earth materials. He's an academician of 7 international academies. And also, just like Sylvester Gates, he is also a recipient of the National Medal of Science, one of the highest award bestowed to a scientist in the United States. So let's have his video.
I appreciate very much the kind invitation by Professor Da Xuanfeng and the Nanjing University Alumni Association, United States, to speak at this symposium in honor of Professor Jianxiong Wu. It is my greatest honor and privilege to have known the marvelous Professor Jianxiong Wu. Here's a picture of Professor Wu in the 1940s. It radiates her brilliance, thoughtfulness, and kindness. This is the Department of Physics, Pupil Hall of Columbia University. This was where I first met Professor Wu in 1954, shortly after beginning of my study as a physiology graduate student in Columbia Medical Center. Here's a picture of Professor Wu working in her laboratory. Even though she was extremely busy, she would talk with me when she had time about life and the science. She gave me the most valuable advices on the fundamental principles of pursuing research, including to select important problems, be creative and innovative in research planning, be rigorous and accurate in research education, and to combine experiments and theory. These most precious advices provided me with a lifelong guidance throughout my academic career. In 1981, I was president of the Chinese American Academic Professional Association. I wanted to invite Professor Wu to give a keynote lecture and receive the Outstanding Achievement Award. With all the wonderful awards Professor Wu had received, I thought this was such a little thing she might not want to accept, but she kindly did. And she gave a most inspiring and exciting lecture to the young scientists attending this meeting. This is a picture of Professor Wu and her husband, Professor Lu Yuan, in a Chinese restaurant together with me and my wife, Casey, and the Jian family. Dr. Koming Jian was my PhD student, but he went on to become a wonderful doctor and a professor of medicine. He was the private physician for Professor Wu and Professor Yuan, so we all got together quite often. Professor Wu has received many outstanding awards, and this is one of them, that is the honorary degree and the Episcopal Medal from the Padua University in 1984. Elena Piscopia was the first female doctor of the world more than 3 centuries ago. And this is the medal in her honor and was received by Professor Wu. Upon her return to New York City, he kindly gave this precious medal to my wife, Casey. This was most generous for her, and we're grateful and most appreciative. Professor Wu also gave me some of her communications with Dr. Hu Shi, who was a superb Chinese scholar who led the language reform in China. And he was one of the most outstanding Chinese scholars in the 20th century. On the right side, these letters are in Chinese. On the right side, that was his saying. He wrote in large fonts that translated into, if you would like to have a certain type of harvest, you must first do your cultivation in a particular way. This is an excerpt of a letter from Dr. Hu Shi to Professor Wu. It says, "Dear Jian Xiong, meeting with you overseas, I'm very pleased to know that you have a strong resolve to pursue advanced studies. In pursuing scholarly activities, one needs talent as well as effort and diligence. The paradigm about the turtle and the rabbit is meant to encourage people below average, but it is also a warning for the talented. It takes a combination of the rabbit's talents and the turtle's efforts to become peerless in the world. Best wishes, Hu Shi." At that time, Professor Wu was in her early 20s. And this her reply to Dr. Hu Shi says, "Dear Teacher Shi, a few weeks ago, I found a letter you wrote me when I was a student on the West Coast. In the letter, you give me tremendous encouragements and most valuable advice, which I shall always remember. I've made a copy and forwarding it to you. In my whole life, the people who have had the greatest influences on me are my father and you. Unfortunately, father passed away on January 3rd this year in Shanghai. I'm deeply saddened that he and I will never meet again. Best wishes, your student, Jian Xiong." I have given these letters to your Central University for them to keep or display. In Taiwan, there is a Wu Jianxiong science camp since 1997. I've attended 4 of these, and most of these were held in Chitou. Chitou is in the center of Taiwan, high up in the mountain. It's a wonderful area with mountains and water. And this camp is usually attended by more than 100 students, college students, mostly from Taiwan, but some from other parts of Southeast Asia. This is a group picture, and enlargement of the picture in the front showing me sitting with President Chi Hui-ong on my left, and the organizer, Academician Liu, on my right. I give several lectures. One of them is entitled "Interplays Between Science, Medicine, Technology, and Humanity Society." In the last slides, closing out the lecture, I showed the picture of the solar system on the top with the sun in the middle and the planets, including Earth, orbiting around. The bar here is 10 to the 10th meters. In the bottom of the slide shows the carbon atom with the nucleus of the carbon atom in the middle and the electrons orbiting around. The same scale, the line is 10 to the minus 10 meters. So the difference in order of magnitudes is 20 orders of magnitudes. So that is 1 with 20 zeros. After that, that's how many times they're different. And yet they have similar principles of how the elements are orbiting around the nucleus. In the doctrine of Ming, more than 2 centuries ago, Zhongyong, it says, "Release it and it will fill the universe." The Chinese 放子者弥六合. Retract it and it will become invisible. 转子者对藏于密. I think the "it" here refers to truth. The truth is the same, regardless of scale. If you retract it, it will become invisible, like what Professor Wu was working on in the intranuclear particle interactions. But what she worked on, the truth can be expanded and fill the universe. This is how great Professor Wu's work was. So I want to close with my greatest respect, admiration, and appreciation to Professor Jian Xiong Wu, and also express my best wishes for the health and happiness to everyone. Thank you.
Thank you very much, Professor Chen Xu. It's always so humble to listen to you, looking at your great scientific career, and you have made such deep feelings as how Professor Wu impacted you. It's really, thank you very much. Now, I'd like to invite Professor Bao Zinan, who is a professor at Stanford University. But more important also, she, of course, is an alumnus of Nanjing University. We thank you very much, and the screen is yours.
Thanks, Professor Fang. Please let me share my screen. Okay.
Yep, here it comes.
All right. It's very much my honor to join today's celebration of Madame Wu's 110th birth year. And she is one of the most influential nuclear physicists and the most renowned scientist. And also as alumni of Nanjing University, I'm also very much honored to be associated with Professor Madame Wu as alma mater. And it's worth noting that at the time when she got her PhD in 1942, there was no single female professor in any of the top universities in the US. And I grew up in China, in Nanjing. Nanjing University was where I learned about polymer chemistry and learned about how to do research as my first experience. This is what I remembered about Nanjing University when I grew up. The left picture is where physics department used to be. And my father was a physics professor at Nanjing University, and he would frequently tell me stories about Professor Wu and other great physicists. And her story especially inspired me because as an Asian woman who can be so dedicated to science and also being so resilient, and her intellect has inspired so many people, and especially myself, to pursue a scientific career. And because of her and many others who have really fight for the recognition for women and to raise the profile of female scientists, I have the fortunate to be able to work at the intersection between chemistry, physics, and engineering and the medical area. And what we are inspired about is to develop a future of electronics that completely change the current status of electronics. Imagine this little baby who was born prematurely with catheters inserted in her little hand, which is same diameter as human hand, as our finger, and that can cause a lot of damage to this little baby. And also imagine having the telemedicine that we have today, but being able to actually feel the allow the doctor to feel the patient and perform examination while through the not be really present physically. And also imagine being able to quantify mental state and allow us to be able to diagnose depression or anxiety that impact so many people in the world without currently, the only way to diagnose is to use a symptom and talking to the doctor. So that's what we hope to change. But the challenge is today's electronics is rigid and brittle. And what we really need is to have the electronics being comfortable, invisible, imperceptible, biocompatible, and autonomous, so that we will be able to use them to interface with human in an intimate way and without being noticed. So we use human skin as the inspiration because they are flexible, stretchable, biodegradable, and self-healable. And we started working on this in the early 2000s. And first start from trying to mimic the sense of touch of human skin and develop the electronics that start to be able to generate signal that is able to directly interface with human brain. And there we have to start with first developing the new materials and understanding the chemistry to build integrated circuits so that we will be able to eventually build a piece of electronic skin that is truly skin-like. And today, we do have such a new generation of electronic skin that we start to test with animals to see the signal, how they can be used to control the movement for paralyzed, potentially for paralyzed patient. And really the enabling part is to understand the materials chemistry so that we can design new materials, new polymers that overcome the disorders that are intrinsic to these materials to enable a number of conducting polymers, semiconducting polymers that with added functions such as stretchability, self-healing, biodegradability, and without compromising the electronic property, but rather enhance the electronic property, such as making these electronic skin that can sense the location of objects and being able to measure electrical signal from creatures that were not possible previously. And finally, also making new form of display that are stretchable. Also, there are sensors that now are skin-like that can be used to measure heart, muscle, the brain, and also neural signals from both the brain and the guts. So today we hope that in the very near future, we will be able to have wearables that are skin-like, that be able to put conformally to the little baby to allow the premature baby that I showed earlier to have ways to monitor their vital signs without causing any potential damage to their body. And today, we're working with scientists from all different disciplines at Stanford and throughout the world to hope to advance precision health, telemedicine, and the metaverse. And again, I thank Professor Feng and Nanjing University and all the organizers for the opportunity to celebrate the life and achievement of Professor Wu and her dedication, resilience, and the deep intellectual will continue to inspire many generations to come. Thank you.
Thank you very much, Professor Professor Bao. this was a fantastic talk. I can only use that word. 20 years ago, I first learned from my good friend Alan McDermott the idea of a conducting polymer. And I see that in 22 years, it has moved far beyond into real life science. Thank you again for allowing us the opportunity to listen to you, and that you're from the same institution that nurtured people like C.S. Wu. Thank you again.
Thank you.
Okay. Next we have Professor Yan Ning, who is a distinguished professor in molecular biology at Princeton. Again, Princeton, of course, is very important in the life of C.S. Wu. And of course, she is also a member of the U.S. National Academy of Sciences. The screen is yours.
Okay, can you hear me?
Yeah. Yes.
All right. Hi, everyone. First of all, I would like to thank Professor Feng for inviting me to present at this meaningful, memorial symposium. I feel both honored and humbled to speak together with so many distinguished physicists. I myself is a biologist, but as I think about it, I'm remotely related to physics in that I'm also a biophysicist, because I always say biologist, and physicist is not even a term that I usually use. But when I think about, so I also have the honor to be on the organizing committee, although President Feng and others have done most of the job. Thank you so much for inviting me. And as I think about it, my path has remotely crossed Professor Wu's probably in three aspects. First, like when I Googled, this is not the first time, but previously when I Googled C.S. Wu's quotes, this is the first sentence shown in Google. It is shameful that there are so few women in science. In fact, I've noticed that from many forums and discussions about women in science, we've discovered this scissors difference phenomenon during the development of female scientists, as shown here. This is statistics. Actually, it's written in Chinese because I got this slide from Ms. Fang Xin, who was the chair of Female Scientists Association. And according to this statistic, as you can see, this is a censorship diagram. At the beginning, so there are almost equal numbers of male and female as students, as from elementary school all the way to even college, and then even to graduate school. But then when they follow the track to PIs, to assistant professor, and academician, the difference is obvious. Although the situation has improved 3 years, from 1986 to 2006, as you can see, the ratio of female scientists at advanced positions have increased by about 10%. But difference between genders is so obvious. And why is that? And there are many discussions, so I will not go into details. But when I think about it, one important factor that affects people's choice, apart from the cultural, the social, the historical impact, just as individual, how much we have been influenced by our role models. Like for myself, I started as a student majoring in biology in Tsinghua University. I always thought that I was not good at math or physics. But then when I read the stories about Professor Wu, about Madame Curie, about like other Nobel laureates, there are only very few female Nobel laureates in physics as well as biology. But when I read their stories, I realized, yes, we can. I mean, we can do science. Like, we are smart, we are brilliant enough. So when I joined the graduate program of molecular biology at Princeton University, I chose Professor Yigong Shi's lab for X-ray crystallography. So that's already related to physics. So I was not afraid because I knew female can do it. And apart from all the pioneers like Professor Wu and some of the people you are familiar with, but some like Rosalind Franklin, who actually got the X-ray diffraction of double helix, which led to the discovery of the double helix of DNA, and also Professor Ada Yonath, who is the Nobel laureate who crystallized the ribosome, and the structure was then resolved using X-ray crystallography by two other scientists. And also in our department in Princeton, as shown on the bottom row, as you can see, I was surrounded, as a graduate student, I was surrounded by female full professors. So for us, gender was never an issue. Gender was never a hurdle to prevent you from doing research, from being a scientist, from being a full professor. That's why, within this environment, I never doubted myself that I could not do science after I entered the graduate school. And when I returned to China in 2007, I established my independent research program. And there, I was also inspired. I had been inspired by great female scientists. I have been and I am always grateful to my three mentors, Professor Wang Zhizhen, Kong Tingyun, and Xu Yunyu. So two of them are biophysicists, actually, and they have given me great support and courage. And so, with these role models, I was never afraid of tackling with the most challenging scientific problems in biology. So my research focused on the structure and mechanism of transport proteins, which are, as a structural biologist, these proteins represented the most challenging targets because they are membrane proteins. So their functions are quite diverse. They mediate the uptake of nutrients, the extrusion of metabolites, and also the permeation, the selective permeation of ions. So my lab has been focusing on the structural and mechanistic study of glucose transporters, which mediates the cellular uptake of glucose. Glucose is the primary fuel for life. And we are also interested in the structure and the function of voltage-gated sodium and calcium channels, which are responsible for the initiation and propagation of action potentials, basically the electric signals that control our neural activity. So using X-ray crystallography, I was lucky, although, these were very challenging. With my great team, we were lucky enough to solve the first structure of human glucose transporters. Shown here is actually the crystals. Probably some of you are familiar, and with X-ray crystallography, we were able to solve their atomic structure to 3.1 angstrom, and this gives us a hint of how they may function. Then, with advanced biochemistry, we were able to solve their structures in different conformations. Eventually, we can come up with a movie to show how this molecular machine mediates the uptake of glucose into the cell. So I will not go into details about this research. So then in 2017, because of my work in membrane transport, I was recruited back to my alma mater, Princeton University. And here I got, another, so for the second time, I think I overlapped with Professor Wu in that she was the very first woman hired as a faculty member in Princeton's physics department. I'm sure you all know about that. So the physics department is just across the Washington Road from our department. And so I have been thinking, no, when I read this, like in early 1940s, and the first female faculty member, look, I was surrounded by female professors. I was empowered. But when I try to imagine what she felt like at that time, how lonely she might be, I really admire her. And I think, the best way for us to show our gratitude is really to pass on this inspiration. Therefore, ever since 2015, I have been organizing a forum on women in science. So I invited female scientists from different universities from all around the world at different career stages to share their experience, to share their lessons, to give each other support. So this has been very, I would say, very rewarding, because with years, more and more people told us how, they've inspired by these role models. From this, we see, the power of role models. With this, thank you again for giving me this great, this opportunity to express my gratitude to Professor Wu, one of the pioneers in science, and she has inspired me, and I'm sure she will continue to inspire generations of female scientists. Thank you.
Thank you very much for that inspirational talk, as all the others. We have come to the end of this really historical event, and I've been asked to say a few words of conclusion. Not that I know how. I'm going to just scratch my head and try to say something. One of the things I hope we take away from today's is the following. We all have learned for the last 60, 70 years that Madame Wu did the parity non-conservation experiment. It was so spectacular that it basically outshined everything else. Well, that just ain't true. Her other works, as was pointed out by my good friend Lex, her other work is just as Nobel quality as possible. I'm so glad that the word entanglement came out today, because as we all know, entanglement is now one of the hottest subjects in physics today, in quantum computing and quantum information. So I think that we should not get the wrong impression, and I hope today we cleared it up, and that is Madame Wu is not a one-trick pony. It's a many, many, many trick pony. Secondly, I think I also want to dispel the notion that she is only inspirational to young female scientists. That ain't true. She is inspirational to young men, middle-aged men, even old men. The same, of course, with young ladies, middle-aged ladies, and old ladies. She is just inspirational. Never mind the gender. There is no gender bias in terms of her inspiration. She was simply fantastic as a human being, as an inspirational human being. Finally, in today's geopolitical and political chaos, what we show today is that she was, and in fact is, a tremendous bridge, of the most mega-sized bridge between two of the greatest nations on earth. At least that's what we say. I think she loved the United States and she loved China. You don't have to love one and not the other, because both have deep cultural roots, both have deep cultural meanings. Now, America is a little short on history, and China is overabundant with history. So those are the things we can all learn from each other. And Madame Wu taught us that. And today, from every speaker, even the politicians today, that came out loud and clear. So I think today's event went way beyond just honoring her as a great person, as a great scientist, but I think we have established a platform for humanity where she plays such a fundamental role. And so I am so deeply honored that Nanjing University's North America Alumni Association asked me to work with them to come up with this. And of course, all the organizing committee members that has been involved in this very, very big effort have been helpful in the last 6 months. There are too many names for me to name to thank. I'm just going to say, 谢谢. Bye-bye.
Okay, thank you, Professor Feng. Bye-bye.